somebody wanted to know about neutral density filters and how we would use them for assessing the pupil response and measuring a relative afferent pupillary defect. So I happen to have a series of neutral density filters here, and you can see that the light passes through each of the filters and it gets progressively darker and darker and darker. On the side of the bar, it says what log unit it is. 1.8, 1.5, 1.2, 0.9, 0.6, 0.3, ranging from the densest to the least dense filter. And so when we're swinging the flashlight in the relative afferent pupillary defect test, we're shining a light. Well, as you know, when we shine the light in this right pupil, both pupils will constrict. And then if we swing the light back, if we have a RAPD on this right eye, for example, then that right pupil and left pupil will dilate when we swing from the good eye to the bad eye. And the way you use this is we can put this filter over the good eye to neutralize the relative afferent pupillary defect. And thus, when the light swings and it fails to produce the RAPD, that's the measurement of how big or how severe the RAPD is. So if I swing the light and it's dilating and I put the 0.3 over there and I swing the light and it's still dilating, then it wasn't enough. So I put the next one up and then the next one until it neutralizes. And if I put the next one above that, it'll reverse the RAPD to the eye that has the filter on it. So we can measure an RAPD with this. However, it really isn't that great because who cares how much measurement it is? What we're really interested in is it there or not. So for me, the best use of it is this 0.3 log unit filter. And the reason that one's the best is because this 0.3 log unit filter can help adjudicate question mark RAPD, or maybe there's an RAPD. Because if it's a trace RAPD, and you want to know if it's real, if I put this 0.3 over the bad eye, the affected eye, it'll make it more obvious. And if I put it over the good eye, it'll neutralize it. And so it's really great for adjudicating it, because if I put it over the good eye and it reverses the RAPD right away with the 0.3, well, maybe it wasn't a real RAPD after all. Yeah. And if I put it over the bad eye, it'll make it more obvious. But what if it doesn't do anything? Well, then maybe that was a fake RAPD. So a 0.3 log unit filter is really great for adjudicating, is this a real RAPD or not? The other filters are useful for measuring in a quantitative manner the RAPD. The endpoint is reversal of the RAPD, or it stops being an RAPD, and you're going to put it over the good eye.